Okay, hypothesis testing of a binomial distribution. Okay, so we're told at the top that the chances of the drug treating an illness is 78% or 0.78. We're then given some information to test there where it says that, that they think that there's a high percentage of patients will be cured with a new test, right, where out of 20 patients, 19 are cured. Then it says carry out a hypothesis test at a 1% significant level. Alright, so the first thing we do is to talk about the null hypothesis, which is that p is still 0.78. Alright, so there's my null hypothesis written down. And then the alternative is that p is actually increased. Alright, so p is greater than 0.78. Okay, that then leads us into looking at this. It's a one-tailed test because we're looking at p is either increased or decreased. And then, look, we're going to do this in two different ways. Okay, the first way is just down on the left-hand side of the page here, where we set up our distribution that x is binomial, but n is 20 and p is 0.78. Now, we know that the value we saw in the sample was 19 out of 20, and we want the probability were at least as extreme as this observed value. So to do that, the probability x is greater than or equal to 19. I've used my calculator in mode binomial CD on this one. So it's 1 minus the probability that x is less than or equal to 18, which is 0.0462. That probability, look, is more likely than the 1% significance level. Right, so in other words, right, that means it's not significant, so we accept H0, but the P is still 0.78, and we reject H1. The alternative way of doing this one is again to start with a binomial distribution, but this time we're going to look at a critical region where we work out in advance what x value is going to be significant. So in other words, we want the probability that x is greater than or equal to a value here is smaller than the 1% or 0.01. Right, so again, if I'm using my calculator, that's the value I've just worked out, so it hasn't changed. And the value that x is greater than or equal to 20 is 0.07. Right, so what that means is 20 is the only value which is in the critical region, 19 isn't in it, so again, right, as the other one, of course, accept H0 and reject H1.